Good morning, everybody, and thank you for being here today in this routed session. I would like to start by introducing myself. My name is Tomás Carbonell, and I would like to talk a little bit about me. 30 seconds, actually, for you to know the background of my presentation. First of all, I would like to thank the CSCN team because we are working together to come up with a guide about securitizing containers, Kubernetes, and implementing DevSecOps in the real world. And they gave me the opportunity to be part of this session. As I said before, these are common topics: containers, Kubernetes, microservices, DevSecOps, etc. In this regard, it all started, in my case, a couple of years ago. I've been working in security for 15 years, working with different service providers, infrastructure, security, etc. And then, on a personal note, my hobby is robotics, and I try to I always have moments of freaky moments at home. So I realized that it was very difficult for me to work with a server at home. I only work with a virtual machine, so I couldn't raise virtual machines for everything I needed. So on the internet, I read that many applications happened that are lighter and running faster.
Then I took entry into this world of containers. I started understanding this, and I'm based on what I have at home, and I'm going to show you some domotics and some applications I've developed. Professionally, I had some friends. I had the pleasure to work with some people. The company I work with started investing in containers and cloud security for a couple of years ago, and since then I am working in this cloud security issues for the Southern European region. Having made this introduction, what we're going to see today, cloud containers, is something new. The overview, a general aspects, what's happening within organizations, the way the development cycle has been changed, and the challenges we have for the world of safety and security. Security is an issue where you work at, and we have important challenges ahead. Let's talk about real cases. We'll talk about our cyber intelligence group, the type of threats we have, what we've witnessed in the last few months. We'll also talk about the framework, a framework we're going to propose. We're going to propose a reference guide, a framework to implement securitizing containers and in an organized way, and to take into consideration what other organizations are doing. Last but not least, we're going to have a small demo on what we're going to present. We're going to talk about real cases. We're going to use different tools. And we're going to see the attackers. We're going to take countermeasures, and we're going to enhance effective security measures. If you are in a hurry, let's start, and let's start by the conclusions, the end. What I'm going to mention, first of all, is that the status quo is changing. There is a dynamic environment. Security and development teams, the relationships have changed. How many of you working in the field of security, how many of you are considered as, well, the strange guy? Dr. No, yes, well, I have two things to tell you. I have bad news and some good news, and you're used to it. You're used to it, to be the bad guy. But this is going to change, and it's going to get even worse because iterations and development cycles are changing. We're going to see here we have applications that were reasonably monolithic, and they were managed to have releases. We had special releases that were several, 2, 3, 4 per year. 3 per year maximum, and we're working to the opposite side. Development teams are now quite fast. They have automated things, and they're using debug models. That's fantastic for companies: digital numeric transformation, new services, e-commerce, IoT, and so on. We're enhancing competitiveness, and if you allow me to say something about it, those teams, development teams that were based at the basement of the companies have always been at places where we were never been considered. Now They are at the most beautiful floor, the most important part of it, but we, security, are well behind. That happens because the status quo is changing, has changed, and we have to work together. This is teamwork. It's one of the conclusions I want to put on top of the table. Cooperation means shaking hands, learning one from another. Automation and the speed is enhancing, but also they have to learn about security issues. They have to learn about what we've been doing for years, identifying vulnerability, accomplishing with the different rules and regulation frameworks and forensic analysis, what we've done for years and years, what we will keep on doing. That's our main objective for today, trying to implement security controls during the development cycle that's changing, improving, or has already been changed. And now we have the conclusions. So if you want, you can go home. No, that's a joke. We're going to start now, the introduction, some data. I'm going to give you some information that's going to prove that what we're doing is reasonably true. First thing is that 8 out of 10 companies have adopted the transition from the old applications they had at corporate level into new things. It does not mean that the public cloud have that. There are some native clouds developed. They have containers, adopting containers, microservices, on-premise environments, and also cloud environment. Those are shaking hands, but they should go hand in hand. Containers were technologies that were used years ago in the case of startups, top technology companies, but now that's a reality. They're here to stay. 1 out of 2 big companies are using containers nowadays for productive environments, not experimentally, not for games, not for tests. We're talking about applications that are used nowadays. In 2020, we talk about 50% of companies next generation in terms of computational efforts. The serverless approach is adopted by companies. And as you see here, 2 out of 10 companies will adopt the serverless approach this year, 2020. Some examples I want to give you. First of all, that comes from a company, Datadog, that observes and monitors infrastructures and applications. Datadog published a study a couple of years ago, but it's still valid for our conclusions. And what we're going to say, what we have said is that the growth of containers is exponential. We said back in 2018 that 75% growth took place, and they were saying that next edition that's about to be released is even growing faster. How about it? Environments are orchestrated with different types of approaches with a big impact for organizations. The deployment of containers mean we need to orchestrate this properly. Last conclusion we have is that in spite of this being originally linked to startups, big companies are doing this too, and big companies are using containers. As we see data here showing what we said, that's a reality. Another example, Google. Google is running everything on a container. All the infrastructure migrated towards containers. In the case of Google's, and we have here some data, Google, they have 2 billion containers per week, and if you have them, that means 3,300 containers per second. That means Google, they are deploying lots of containers during the minutes I'm talking in front of you. That's fantastic, but speed means we have to pay the price. We have innovation, we have a problem, which is security. Security is a problem. We've forgotten about security. It seems that it's taken for granted. And the deployment of containers and microservices, the speed is achieved. On the one hand, we have here that we reuse libraries, images, codes, and on the other hand, this use of codes, libraries, and images, it's not free from vulnerability. We have to reuse them, and that's obviously a problem for us people working in the field of security. On the other hand, we have to start while developing things to think about security issues. We had already given security auditing and testing applications, ready-made applications, and we gave a go-ahead or not. But now we have to start implementing, checking security issues in the case of developers. And as far as myself, I work in the field of industry, and I work for a service provider. As a company, as an industry, we're not able to give tools that are appropriated for updating and coping with this new environment. And there is a trend. The trend, and has been anticipated before, it is what's known as the minimum exposure, the shift left. We're going to have secure applications, and the security team will survive if we're going to implement the sooner the better checks while developing things. The repository of codes, registries, images, and content and everything is to be checked according to security parameters. We should secure files, transformation, whatever files, whatever deployment of infrastructure, and should be checked as soon as it's been written. While creating images, we can generate, we can analyze the way the images are created, we can look at the files, we can see what makes or takes part of the deployment. If we're able to participate in those parts, those steps, we could reduce the exposure of iteration, and we won't be exposed or overexposed to risks. So risk management. How about the new ecosystem? The new ecosystem. The first time I started getting familiarized with this, I got familiar with this, and there is a lot of creativity. I saw beautiful logs. Logos were fantastic, and I love colors. But having said this, we were seeing 4 big blocks where we can work at. Repositories, code repositories, and this would look like a big hog, a big bucket, big whatsoever. We're talking about continuous integration tools, continuous deployment tools, runtime tools, or whatever type of registries. And we can deploy containers or whatever microservice in infrastructures using guides or whatever it's been given by cloud provider services or serverless, as I said before. We have different workloads for different cases of using this. We'll have different deployments of different applications at different levels or different types of workloads according to their prerequisites. If they need a bigger control of all the thing, we'll start with a physical or a virtual machine. If we have something we can take, if it is a cloud architecture, you can use containers. Or if we need a dynamic approach, we could talk about serverless environments. That does not mean that if it is serverless, we're more mature. No, we do think that being mature means to know what to do at what time and which technology could be used for a given application. It seems that containers are a good compromise solution. This is why they have a lot of success. This is why they had a lot of acceptance. In my case, as I said at the beginning, containers allowed me to deploy services, a set of services, where we work with an old server, and we could have connections, we could deploy servers of NQTP, whatever services I'm going to explain, I'm going to describe in a while. We were saying that containers, and it looked like this is a type of workload that gives a lot of balance, and there are 3 characteristics I want to mention about containers that make containers unique and special. First characteristic, they are minimal containers. They are very light. It is an operation system. It is the smallest operation system for deployment, and also we can declare. What do we mean by declaring things? That we can learn lots of things regarding security, configuration files, and so on prior to executing or running them. We can learn lots of things, and they are steady. The principle of steadiness is very important for me because the container is created and dies hypothetically. remaining the same. It's a steady thing. No one gets connected to a container to patch it. You start a new one and you replace the old container. That is something that is quite specific, and this will help us to enhance security in the case of containers. And to end my introduction, I'd like to summarize saying that what's changing in the field of security, four big ideas. We have more entities and bigger workloads. We have microservices, we have very many entities. Those entities might be containers, functions, could be orchestrated containers, and they might be deployed in whatever type of cloud and whatever service is managed and what cloud providers offer. Those microservices and containers will change in a very dynamic mode. We're talking about short resources. They will last for 15 minutes only. IPs are not relevant, and we're going to identify resources according to the image. And security starts by developers' work. And last but not least, security should be portable as a container is portable. One of the principles of containers, soft containers, is to take the container to scale it up as we need, and security should follow at the same speed. And if we are not able to define processes and tools according to this principle of portability, probably we'll have a problem. And the problem will be scalability and how to scale up real cases. In this second part of my presentation, we're going to give three examples: registries, repositories, and worms. Unix 42 in our research team. In the last few months, we've three reports that are relevant, and I would like to show them to you. We have then the Docker registry explorers. We see that the Docker registries are important because developers create codes. The code is packed within images. Images are deployed in registries and repositories. Registries are on the internet. We have Docker Hub and some other registries. In Unix 42, we have developed one step forward. This is a process that we have divided into 5 steps. We start looking for a response to header, the Docker distribution AP version, and with a specific response we understood that was accessible on the net, on the internet. Second step was to check the release. If we get it to 100, that meant that we were identifying that we could have access to it. And we identified in the next 3 steps if it was possible to exert different operations on the registry. Can I have a pool of the images? Can I take one and download the image? We were sending commands iRepository and list tag and waiting for the 200. If we wanted the opposite direction, sending an image to the registry, what we did was to send a command blog upload and to wait for the 202 status. And last but not least, it is deleting images out of the registry. We decided to have an image deletion, and we waited for 400. And then everything was done, and we were based on different tools. We saw there were 941 Docker registries on the internet, exposed on the internet. In general, 18% of them were using HTTP. The other ones were using HTTPS. But what was a concern for us is out of 941, 117 registries were available without any sort of authentication. That is unbelievable. We shouldn't allow this. This is not possible. This is not a security. It's a proper configuration. Registries were exposed to in the internet, and among them we have here that there were sets of registries. 92 and 80 were allowing us to have push and pull operations of images. 7 were allowing us to delete images. And when we have access, then what we saw everything. We had all the structure of repositories inside. We could see all the tags of all the different versions. We could even download, replace images, delete images to take control of the registry, 100% control of the registry. Last but not least, what we saw is that small registries are more vulnerable. Small registries, and we talk about not mature companies, smaller companies, SMEs, or where there are no experts in the field of security. And then there were lots of vulnerabilities. Then the second aspect is cloud-native vulnerabilities. The worm, I didn't know about this worm. When I started this report, it was the worm found, got the name out of a Japanese film. It was a big worm that was clumsy and was very slow, and there were bursts, and they were destroying everything. It is a burst light, and the name is a graboid worm. Graboid worm is the name of a Japanese worm, and it was the first graboid worm that propagates using the runtime container. In this case, it is the community edition, the graboid first ever worm found, and those images, they do not look at the runtime, they look at hosts. What happens within containers is not analyzed. In this case, regarding speed, that did concern 2,000 hosts during the first hour of life. Second example of critical vulnerability is the Harbor project. I don't know if you know about it. It's one of the projects, according to the Cloud Foundation, as Kubernetes, Ixio, and so on. They would like to see, Harbor would like to become an open source registry for the imaging. It's been adopted everywhere. It's widely adopted. Many clients are using this. Many organizations are using this. And we saw a critical vulnerability that gave people the privilege of administration getting the by default version in the hardware. 1,300 were vulnerable, and we worked with Harbor developers to have a patch to solve the problem as soon as possible. We're facing similar problems as those we had coped with during all our life, but we have a new ecosystem, and we have to work together with other people. And third item is to have security of a stack. I'm going to give you a tool. You have to enhance security of the ecosystem. I'm going to give you a tool that's useful, and I hope will be very useful for all of you. It's a paper that was published by NIST, the National Institute of Standardization, Technological Standardization in the United States. And they established papers like this one for securitizing containers. And that was published in 2017. It's interesting, that's what I decided to talk about this framework, because they did not only identify problems, but give us important recommendations. They tell us how to attack them, and they do it in a very abstract mode, in a very agnostic way of technologies. So let's see what the general ideas are.
So on the left, you have the scheme of any development cycle divided into three main stages. First stage, image creation, testing, and accreditation. Second stage is storage of images and sending images to the production area. And the third stage is what is considered run time, meaning deployment, containers, and their management. So NIST and IST identify 6 action points, 6 activity points. And if we are able to implement controls, we will elevating the security stance of our organization. First of all, vulnerability management. Nothing new for you and for those working in security. Vulnerability management is something we've done always. Compliance, being able to implement different compliance framework. Runtime or analysis on runtime, meaning what is happening at a runtime level within a container. That's not new. Malware, secrecy management, and reliable imaging. So let's see them in detail. Vulnerability management. The NIST says that we need to implement specific tools for containers. Specific tool for containers working in the different stages. This is not a problem related to an image or a registry or a container in production. It's a problem that is related to the 3 stages. So when you face this problem, you should not only to detect, but also to establish preventive controls and also to remediate the problem. The NIST mentioned these 3 stages. So images should be divided into layers to see the base operating system, all the libraries, all the frameworks used, Python, JavaScript, etc., in order to develop or create the image. And we should look at the different stages of, obviously, the code. So this is the first recommendation by the NIST. Second, compliance. As we know images layer after layer, we should check the different compliance layers. So if you find solutions on the market, the solution should automate these checkings. So taking a picture today at 10 and another snapshot tomorrow at 10 is useless. So we should check compliance throughout the process. When the image is created, when the image is stored, when we talk about the production environment. Analysis in runtime. So the recommendation is to use machine learning technologies and artificial intelligence in order to understand how containers work. If you look solutions on the market, solutions to respond to your security problems, the NIST says that we need to understand how containers behave. Remember that I mentioned immutability before, portability, etc. So immutability allows me to take a snapshot of a container in a static way and a dynamic way. If I'm able to understand the process is executed in a container, the calls to the systems of the container, the disk activity, and the network activity, if I work in these 4 dimensions, I will be able to detect problems if someone is trying to escalate privileges or vulnerabilities or lateral movements, etc. Malware, that's obvious. And that's evident for us, but we need to make sure our organizations don't have images containing malware, both in production and in resting. So we need to have tools to scan malware. Secrecy, and this is something rather common, and this is one of the main failures our research teams find. So secrecies in terms of clear texts. So within containers, we have sensitive information. So working and integrate tools should be done in order to avoid sensitive information within containers. And we need to decide at organizational level the registry we trust. What is the entorno, the environment we're at? We're distributed an environment, so we will have development, different units, 4 to 1 bytes, depending and relying on different bosses, etc., using different structures, Docker hardware or the Azure registry or other registries. But okay, no problem. As a security officer, you need to define the corporate registry you trust and allow the deployment of images coming from these registers. Otherwise, things will be out of control. Okay, now, everything that I mentioned will be hopefully shown on a video. But let me ask you first, do you want to look at this slide mode or live? Live, right? Let's try. I'm going to connect to my home lab. So it depends on Telefonica and the 4G device I have here. So let's give it a try. I think instead of extending the device, I'm going to replicate it. Okay, I'm going to show you. First of all, I'm going to introduce to you the actors that are going to take part of this. In this case, I have a host with different containers that are running, different images. I use Portainer because the tool, it's an open source tool that is really useful to manage containers at home without Kubernetes or anything, so it makes my life easier. I have different images that have been deployed. I have some containers deployed here as well. I use Heimdall, which is one of the projects prepared by Cloud Netting Foundation. It's very easy to have access to that. I use Trislo, which is a Palo Alto tool, and I'm going to use it for you to see the capabilities I mentioned before, and I'm going to use Jenkins as a pipeline management tool. Also, the terminal is here to execute commands, and the goal of this demo is for you to see the 3 stages identified by the NIST. And we're going to see what happens, how can we launch an attack, and how can we prevent an attack or to take measures to stop an attack. So let's start by the first stage. Jenkins, we have a pipeline that was created, and on this pipeline, if you see, we have 4 stages: preparation, building the image, a scanning phase, and then a publishing phase. So what we've done is we created a pipeline that downloads a Ubuntu image, and that's it. So the image is created, is stored in my image registry. What I have here is in green because I built, actually, that is build 17. Everything is green. Everything is OK. So I'm going to relaunch it. OK, so the demo is not going to work OK. Don't worry about that. OK, so we have the building phase here. This is build 19, and it failed. Why did it fail? So we can have access to the different logs, and we see, I don't know if you can see that from where you are sitting, but we can see that this image has a series of vulnerabilities that has been considered as critical. We have vulnerabilities in the PyJam pack version 3.3.10, and the failure happened because we have an indicator saying that if the vulnerability is critical, this build will be blocked. Where do we see the indicator? When we set up the pipeline. So we go here and we see the scan phase that has a policy saying that when things are critical, the build is blocked. If we edit this policy and we say warn instead of block, and we save the changes, we see that automatically the build can be done without any kind of blocking. See? The build is created, and we publish the image on our registry. This is a simple way for us to integrate security control within 100% DevOps tool. The exposure is reduced, and you can add value and propose value to the people, because people are, or the organization is going to understand how a build is created. Exposure is going to be reduced because the information given here is information that is valuable. Information regarding compliance, Python vulnerability information. So we zoom here to see the description even, and if this vulnerability was sorted out, we could see the version of the solution. So this is valid and valuable because exposure is reduced. All this from a security point of view. So let's go back to the main console to see the evolution of all of these use cases. So what we can see here is that we have different Jenkins issues. So the failure 1.09 and then 1.8 or .8, and this is when it was sorted out. And here we have compliance. So this is the first use case. Integrate a CI tool in order to reduce exposure in terms of vulnerability. But also, we could do the same for vulnerabilities. For example, we edit pipeline, edit setup, and what I do in the scan phase, I block whenever there's a compliance breach. So I save again, I execute the pipeline again, I create a new build 21 in this case. And I have to say, hi, it's not critical. I think violations of compliance are high. They are never critical. If they were critical, I should change the threshold because we have too high here. We could do that, but we are running out of time. So that's why they are high. The second checking is with a created image. Let's think and simulate. We have a created image already. So we download an image. So I go to CLI. I believe I have one here. Wait a minute. Yeah, just a minute. I think I have one here. Okay, here. I downloaded an image, 1.14. Someone in the organization said, this is an image that is going to be used in this microservice environment. So this macro or image, in the registry, I'm going to scan it. It's in a corporate registry like the one I have home, or maybe a registry in the cloud. So we scan the image. I'm going to use PCLI, which is a vulnerability scanner. And we are going to see each one of the vulnerabilities affecting this image. This image is created already. This is the main difference between this and the previous one. We were checking before the creation phase of the image, but now we are looking at the image that has already been created, and we see vulnerabilities, critical, high, medium, low, or if we have vulnerabilities in terms of compliance with the standards. So vulnerability, high vulnerability, Docker benchmark, CLS. So if I want to run this image in spite of all these vulnerabilities and run the container, I have to execute this command. I execute the command, and I get the container being executed. Where can we see that? We can see that. We can see that here. So my containers here on the list. All containers, as you can see, Nginx. So this is a running container with all of the vulnerabilities. What can we do to prevent someone launching images like this one with many vulnerabilities and compliance failures or breaches or violations? Well, we can use a free version of a tool, and we decide an image policy. For this case, we add image policy for Nginx, and we're going to receive alerts on vulnerabilities, but we are going to block only critical vulnerabilities, and we'll do that for any image on Nginx. So we save this policy, we stop the container in this case, we pause it, and as you can see, it stopped, and we run it again. As you see here, the failure, we could not restart the container because there is a policy saying that this container has three critical vulnerabilities. So this is a simple way to implement policies to reduce or block exposure of images our DevOps teams want to develop. So speed is important for DevOps teams. So because they have to comply with deadlines, they have a weekly or 2-week sprints, and they want to be in time always. So vulnerability is not their main concern. So we need to make them be more involved on a daily basis with the vulnerabilities and more concerned about them. So we can see also the different events that happen. So here we have all the running containers. So we have the Nginx container here and events, and we see the vulnerabilities that have been blocked in this image, Nginx for 114. So we have a traceability. We can see the things that have been blocked, and as a security team, we can have an overview of all the things we've done. So first example, build. Second example of the deployment of images in the infrastructure on on-premise registry, because I have my own server. But we might scan any kind of service on the internet, any public registry on the internet. In this case, registry, NC2, Azure, OpenShift, etc. And what I did is to look at this repository all time, and I'm scanning the five last releases. So monitor vulnerabilities, and we can see here the 5 last releases and their exposure. This is a completely public repository on the internet, and nothing has to be downloaded to get information. And version 3.8 has a critical vulnerability in the DCBox package, and it was corrected in Talversi. So just to conclude the demo, let me show you the last actor. This is a container, the green duck DNS, and I use this container to update my dynamic IP I have home. The only job of this container is to keep in a DNS my home IP. So let's simulate that we take control, that we exploit a vulnerability of this container, and that we try to leave a file, try to write something on the runtime on a folder, in a folder. So this container, in this case, we have it here. I have access as a route. I'm connected. I access temp file, and I create a temp file text for any kind of malicious activities, and I leave it here just for the malicious activities. In this case, I write the thing here, perfect, my written file is here. When we talked about process and containers immutability, I've learned that this container, DNS container, behaves as follows. These processes can be executed statically or dynamically. I've also learned that no network communication exists in my ecosystem. I also learned that there's only one folder to write files, and these are the calls to the system calls of the container. So I can implement a runtime policy on this container, and the thing I'm going to do here is very simple. I will generate alerts for unknown processes, alerts for communication outside of the communications I know, 443, and alerts for activities outside the disk that I'm not aware of. But I'll do that, and I'll do that preventively. I'm going to block any disk activity outside of what is considered as normal. So back to the container runtime, disconnect, connect again, same operation, temporary folder, temporary file. I write another file. So I write the file, and what I get here that the operation is not permitted. So we see that this file is out of the model, and because we have a security control in the runtime, this operation is blocked. If we see the different events, we'll be able to see one activity that was prevented, and we're prevented to write the rooted dot file. As a security team, we might be interested in having forensic analysis and having the entire life cycle of this container, and to that we have access to everything has happened since the launching of this container up until the current time. So this is the end of the demo, and my presentation is also concluded. So I'd like to summarize some of the conclusions we've seen today, and if you have questions, I will be more than happy to answer to the questions. The first conclusion I would like to share with you is that the adoption of all this cloud-native application changes the status quo. The relationship of our teams have changed, so we need to adapt. We need to find a way to be more coordinated and complement each other, security and DevOps, in order to make a digital transition easier and to continue being operational in organizations. The third conclusion is that we should have a framework. Organization must have a framework, something that will allow us to implement cross-cutting solutions, and then try to find solutions on the market so that you can apply security controls effectively throughout the cycle in a cross-cutting way. Thank you for your presentation. I hope this was interesting for you, and if you have questions, feel free to ask now. Thank you. Thank you, Tomás. That was cool. That was very well explained and very functional. Now, questions from the audience? No questions? Okay, my colleague here has a question for you. Okay, then. First of all, thank you for the presentation. I think it's very interesting, and I would like you to tell us, based on your experience, what is the most effective way to make developers be more aware about the entire security concept for deployment, creation, and the development of using this applications in containers? I think it's a very good question because it's a moment of friction in organizations. People are more and more aware of security, and teams use vulnerabilities in code tools, SACs, tools, etc. And these are the leaders of that in organization. When I said throughout the cycle, I meant that security teams should be able to educate. That's very important, especially in terms of vulnerability libraries, and development teams use open source services of all vulnerabilities and believe that they can tick the vulnerability checking, but traditional security teams should be able to explain to them that using quality feeds or paying feeds or company feeds is different than using open source tools. What is the difference? False positive, information is not reliable, etc. So I think the first point is educating. We have to explain what we've been doing for years. And the second point is not using tools that are out of the ecosystem. Everything that will be implemented should be within the development and their development cycle. Thank you, Tomás. So please give him a round of applause. Thank you again.